So the sort of scenario we're probably looking at, all of you in the room at some point, or if you haven't already done this, we'll be doing this, where you're front in and you're told it's going to be a BIM project. All the drawings are in 3D. We're going to make federated models. We're going to be using those as a meeting reference point. And we need to share the models via some sort of internet project management system. We've just seen AConneX as an example of that. And so what you'll need in a nutshell, you'll need some fast workstations, you'll need some central storage, good backup, fast internet connection, and some 3D modelling software of some sort, for example Revit. And you need some sort of federated modelling software, or someone will be using some federating modelling software to build these models. And I'll give you an example of Navisworks there. So as a model generation process, you'll be confronting this sort of scenario where as contractors you'll be building models or modelling, creating drawings. You'll be pulling models from somewhere else to link back into your models for reference, an architectural model for example. There may be a project office involved. You may be doing some of this work back at your firm and pushing it out to a project office, or you may be in the project office. But within that project office will be a collection of models and a collection of drawings and so on that have been generated from them. You'll probably have to push that off to an AConneX or an internet project management system of some sort. From there you'll be getting clash reports back. And somewhere out there will be somebody who'll be a BIM manager, and he'll be pulling together some sort of federated models, running some clash reports, pushing it back onto the internet PM system, and you end up closing a loop. So you need to work in that environment, and what I'm going to run you through here is a few examples of the sort of hardware you'll need, internet connection speeds, what's really happening, and so on. This is a table of contents out of a BIM plan. They're all the sorts of things that should be contained in a BIM plan, and these ones are the ones that are going to impact your hardware in some way. Project filing structures, how you're going to structure it, how much do you need, where is it going to be. Site segmentation, if it's a large project, that starts to impact how many models do you have. The stakeholders model structures, how people are structuring models, how many architecturals, how many structural models do I have, do I have a separate mechanical model per level, etc. These are all dependent on the size of the project and how you might be organising yourselves to create them. What are the federated model structures? Is there one? Are there several? Do we have visualisation requirements? Do they want to run movies off this? Do they want to run simple walkthroughs? Are we going to use it for construction sequencing? Are we going to use it for cost estimating? What are the data collection, transfer and release requirements and protocols? How often do they want models issued? How do we do it? Where do they go to? And what do we have to do for coordination and clash detection? It seems a simple requirement, but do you want to clash on a level-by-level basis? Do you want to clash between particular mechanical, electrical, mechanical and fire and so on? How are you going to run the clash? So they're all the sorts of things that impact hardware that you pull out of your BIM plan. 3D model storage files, you've got three issues: storage, backup and moving them around, in a nutshell. How big are the files? This is actually our building. It's a small 3,000 square metre office building over in Batman Street. And to give you an idea of the file size on that, they're the Revit model files sizes, so 171 megabytes in total to move around, and the federated model is about 23 meg. So pretty small job when you're dealing with some pretty large files just to move around. Something a bit bigger, this is the South Australian Health Medical Research Institute laboratory over in South Australia. 28,000 square metres, very service intensive. So there's 695 megabytes of files to move around. It doesn't count the facade file. The facade file you see there is the one that they put into the model, so the federated model was only 82 meg. When we take their real one in, the model blows out to about 300 meg. So again, a fair chunk of files to move around. And if you're going to shuffle those around on a daily basis or a weekly basis, so you can see you need some reasonably good bandwidth to move them. A couple of issues about moving files around. You've got to deal with internal and external. This is just a bit of a slide of different transfer speeds you get out of different devices. Some of those are fibre channels. The SATA disk drives, the sort of disk drive you'd have in a workstation. Flyway 800's a connection you get off Apple Macs to external drives. They're running about 800 megabits a second, or 0.8 of a gigabit a second. USB drives about 640. Wi-Fi, wireless hi-fi, 54 meg. Internal networks, you're running at 100 meg or 1,000 meg or 1 gigabit. Internet connections, usually down about 2 to 10 at the moment until we get an NBN in place. NBN, it will run at a 100 to 1,000, but it doesn't at the moment. So most people are dealing with a 2 to 10 megabit connection. And that's pretty well what it looks like. And in fact, the graph's not quite right because actually inside the computer's up above the 1200 line. But you can see that when you're dealing with a model in a computer, you're up about the 1,000 mark level. When you actually hit your LAN, even if it is a gigabit LAN, it's probably running about 600 megabit. And when you get out to the internet, there's 2 lines down the bottom. The one that's almost on 0 is what you're probably getting out of your internet connection. If you're doing fairly well, you're probably getting about 6 megabits a second. If you use LAN accelerators, someone asked the question, do you get much out of LAN accelerators? Yes, you do get quite a bit out of it. But you can still see it's actually a pretty small blip on the bottom of the horizon. So once you get out of the computer with these models and you want to put them somewhere else, even internally on the network, let alone moving them up and down to a place like AConneX, you end up with a significant throttle. Means you need not only the fastest connection, but you need a plan. A couple of download speeds. These are the theoretical download speeds. So this is what they're rated at, which is distinct from what they actually perform at. There's some good little internet utilities out there. I use speedtest.net, which will give you download and upload speeds to various locations and just check your own connection. But the rated speeds, so if you're doing satellite, you're at 1 megabit a second. So if you're out in the country with a satellite link for the internet and you try and download off AConneX for a 450 megabyte file, you've got a problem. Wireless 3G is not much better. NextG's Telstra is a bit better at 7.2. But interestingly, if you go around and actually run a speed test, you probably get about 3 most of the place in Melbourne, across most of the CBD. If you run the wireless 3G, do a test, I have seen it up about 1.5, but very rarely. Optus usually runs at about 0.6. So again, if you're out on a site office, don't depend on 3G as the way you're going to connect to the net. We run a 10 megabit link into our office. I actually get 6 megabits to most places in Australia. So even though the line's rated at 10, you actually only get about 6 on an upload and 6 on a download. If I go to New Zealand, I get 1. That's over to Wellington. So once you start to rattle out of the country and you start to go across the Pacific and down to Wellington, I also get about 1 to London. So by the time we go out of Australia, across the Pacific, across America, up into the UK, your speed just drops back a fair bit. ADSL and ADS2 will give you 14 and 22, and cable generally give you about 30, and then there's the NBN on top of that. So this is a theory. I took those, if you look at a couple of files, I took that our building at 171 megabytes worth of files, and our other project at nearly 700 megabytes a file. Theory is that the rated line speeds, they're the download times. And on cable and ADSL it looks okay at about a minute to move 700 meg worth of files. But the reality is somewhat different. We actually did a couple of tests, one up onto AConneX and one off a builder's site. I'm not sure where they had it housed, but they gave me the times of upload speed. We did it a couple of times to test it was right. And so that translates into, in the case of moving the 24 megabytes at 500 kilobits a second, half a megasecond, it's 24 minutes to move the files or 5 minutes to move the files. And if I'm at the slower speed, I'm out to an hour and a quarter to move those large files. So if you're hitting the deadline and they say they want them loaded up by 5 o'clock, plan. Now, of course, the other thing that's in play here, when I did my test on our 10 megabyte link, that was about 6 o'clock in the morning. I knew no one else was on it. As soon as someone else gets on it, like me, and decides they're going to download a file, we're sharing it, and we just doubled my time, half the bandwidth. So the other thing, what comes into play here on the 500 megabits a second, that was done in the middle of the day in our office. The Melbourne office itself has a 4 megabyte link into it, but by the time everybody else is on it, and whatever else they're doing, watching YouTube, getting emails, other people uploading, other people downloading, The net result is that of the 4 megabit that were available to them, we only got 0.5 of that. Computers, how fast? Good question. I thought I might give you a little bit of history on processor speeds and how it in particular affects CAD products. The practical limit on clock speed was reached in about 2003. And so what manufacturers did is they then turned to hyper-threading and multi-core architectures. And that's where you have 1 or 2 or more CPUs on a chip. So these days you'll find they're talking about quad-core chips, and generally those chips have got effectively two CPUs on them, so they'll run 8 processors. And concurrency is certainly the next major revolution in software, but it doesn't apply to CAD yet. The problem with CAD is that it's single-threaded. And a couple of other things when you're dealing with computer specs and considerations. Moore's Law. Moore's Law was actually put together by a guy back in Moore in, I think it was 1966, where he worked out that computing power had been doubling every 2 years and continues to have doubled for every 2 years, and they're now projecting that it will continue to do that to about 2050. At the time, he thought it would go for about 10 years, but it's still going. And then there's what Andy giveth, Bill take away. Andy, I forget his surname, was the CEO of Intel, and Bill is obviously Bill Gates, and that relates to every time they double a computer, every 2 years, the software developers generally find a way to use that, and so you actually get no net gain. So you might have all noticed that even though we've come a long way since 1985, the computer still seems to take about the same time to boot. CAD is a single-threaded process that only uses 1 core. So you can go and buy yourself a quad core, you can go and buy yourself 50 cores and stick them in a computer, it'll use 1. And when it comes to memory, as a rule of thumb, the CAD file size will multiply by a factor of about 10 in memory. Operating system, XP or even Windows 7 632-bit, don't go there, it's just got a limit. You need a 64-bit operating system. As I said, workstations by rule will expand, memory will expand by about 10. So I did a little test on a 150 megabyte Revit file. It was a mechanical file for the summary project. That's the graph of the memory workstation usage before and after. So your 150 megabyte files expand in about 1.6 gigabyte worth of RAM. So what's it mean? You really don't need more than about 8 gigabytes of RAM in the workstation. If you're spending more than that, you're just wasting your money. It's not going to use it. If you want to be a bit future-proof, put 12 in. We put 12 in. We think it might give us about 4 or 5 years life out of the workstation. How fast? This is the processor speeds on a Revit file doing an export out to Navisworks. So basically Revit's running flat out. And what you see there is it's only running at 12% because the only core active is the one on the far left. Everything else is just idling. And that's because CAD's single-threaded. What that means is, unlike an image rendering where you can divide the image into 4 and pass it off to 4 processors, CAD's sequential. Has to be sequential. They haven't solved that problem yet. So you need the fastest workstation you can get, but because they had a clock ceiling about, 8 years ago, workstations these days are only really improving in speed because of the graphics card, which affects it a little bit, and the operating system going out to 64-bit, which allows you to use the memory and get some sort of improvements out of them. But workstations these days from a CAD and a workstation 5 years ago with the same operating system will probably give you very similar performance. This, on the other hand, is a workstation running, again using Revit, running flat out doing a render, and as you can see, it's using all the cores. Because from a render, I can take the image requirement, divide it by 8 and pass it off to 8 processors. But I can't do that with CAD. So from a computer spec point of view, if you're out to buy workstations, and I think a lot of people have found themselves suddenly have to do a major upgrade because they've gone from 2D up to 3D and the CAD modelling requirements. Anything with an Intel i7 greater than 2.3 gigahertz will do. 8 gig of RAM will get you there. Graphics cards, anything on the AutoCAD approved list, pretty safe way to pick a graphics card. 64-bit operating system, which is Windows 7 for most people. Disk capacity, if you're running on a network and you're storing on the network, which I hope you are, so you can back up, anything above 200 gigabytes is a waste of money because you've only got the operating system and swap space on it. Disk types as fast as you can get. Network cards will be 1 gigabyte. Screens, we use a single 27-inch and a small 19-inch. That seems to be what the guys seem to prefer as terms of a screen combination. And you're probably spending 3 to 4K on a workstation. So that's your budget. Construction sequencing for 4D. You'll need federated model software, Navisworks or Bentley Navigator. A couple of things you need to do. You need to name, identify and classify components and systems correctly. Otherwise your construction sequencing isn't going to work. Helps if you're identifying components with some sort of phasing parameter. You need to model for construction. And I'll give an example there. Draw the slab as you're going to pour it. Don't just draw a single slab for the level. You can't break it up very easily. It'll interface off the project management software or a spreadsheet, or you can put the sequences into federated model files. A couple of different ways of doing it, but that's the basics of if you're going to go do construction sequencing. The more important one is, I think Paul alluded to this, naming, identifying, classifying things properly so that you can group things, put them into the same level, whether it's for system or whatever it is. Cost estimating, if you're going to 5D, generally the interface is done to the source file. It's not actually done out of the federated files. For example, Costex will use a DWF export. Again, name, identify and classify the components and systems correctly. The degree of accuracy needs to be consistent across the project. It's something that needs to be set up in the BIM plan right up front. But if you're going to do everything to 0.1, like 1 millimetre or whatever it is, it's consistent across the project. It assists if you put the QS parameters in. There is an Australian Cost Management Manual, which are guidelines for cost planning. It has a set of codes. So in our case, we're putting those codes against all the library objects. It just makes life easier for the QS. And it can get fiddly doing the exports. And that's really Costex experience and feedback. So test your files on the target software before you go too far down the track and just see do you have things named correctly, like the parameters are coming out and so on. In the case of Costex, they've got a free viewer, download it, try it out on your files and see how you go. Little bit of bling. Not sure if this will... Where's my mouse? Is this mouse working? It is now. Animations. This is done in Navisworks. Again, you can pretty well run this on one of the workstations. That animation will come back to it also uses the construction sequencing technique. So those techniques to display parts of the system, unhide things and so on is exactly what you're doing for construction sequencing. It's just used in a different way. So those sort of things can be readily done in-house. It's quite within the capabilities of a single workstation, and somebody who's got a bit of a nous on how to set it up and drive it. So again, you need some federated model software to do that. Similar techniques to 4D construction sequencing. Again, name, identify and classify all the systems and components, otherwise you can't decide to peel off the facade or show a particular system in a certain colour and so on. Can be done on a good quality workstation. Simple rendered images, again, that's a rendered image taken out of Navisworks. Simple to do in 3D modelling software. Helpful if the materials and colours applied correctly to systems. So again, this naming of systems and applying materials consistently is important to all of this stuff working. But it's not photorealistic, but you can do it on a good quality workstation. If you want to get into the photorealistic stuff, again, I'll get the mouse working here. So this is photorealistic rendering. This is what they call physically based photorealistic rendering. Again, this is off the Batman Street model, but you can get into fairly real looking plant taken straight off the model. So this is coming straight off the Revit models. Some techniques like substituting photographs of switchboards onto the face of switchboards, turning off the ceilings and so on. But that's going to the next level again. You won't be doing that on a standard workstation. For that sort of work, you're going off to some serious render farms. Again, this is physical-based photorealistic rendering. This happens to be a comparison of LED lighting versus fluoro downlighting. Photorealistically accurate and photometrically accurate. But again, you won't be doing that on your own workstation. That goes out to some render farms to do that sort of thing properly. So the basis is a well-constructed 3D model. Your materials need to be applied correctly. One of the things you should be sorting out at the very start of the BIM plan are what are the materials on the job and how are we going to apply them, and come up with some standards for that. Again, name everything correctly. To give you an idea of how long a still image can tie up a workstation, this image is 22 hours running on a high-end workstation to get that off. That's out of Revit. So yes, you can do it, but after 22 hours and it's not quite how you thought it would be, you'll be pissed off for wasting the day. It can be done, but just realise you won't be doing it necessarily in the office. You need some high-end render farms for that sort of stuff. Lastly, software upgrades. Beware the software upgrade. Software companies generally do annual releases. The US ones are great at it. They release on the 1st of April because it matches their sales year. Regardless of how good the product is or whether it's ready to go, it will roll out on the 1st of April regardless. So they always come on the 1st of April. You can bet on it. We used to have a policy of waiting for the first patch release to come out, because generally you get burnt on the first release. And I think Jeff was telling me a few little problems in the latest release of Revit that don't work, but worked in the last version. But they do come in an annual release cycle. They're often cliff upgrades, and particularly with Revit, it's a thing to watch out for. You open up a 2011 model file in 2012 Revit, it upgrades it, and it's not backward compatible. You can't save it back as 2011. And if you've done that and saved it back for the project, you've just stuffed the whole project team. So beware the software upgrades. It's something that has to be agreed by the entire team. What version are we going to use? Everybody uses it. Are we going to upgrade? Everybody upgrades at the same time. You may need multiple versions of the software on platforms. I know at Autodesk allow you to have 3 versions running on a workstation. You will probably need 3 versions running on a workstation because you'll have projects that are running on older versions and no one wants to upgrade. It's bad enough in the design cycle. It's even worse in the construction cycle because you could be dealing with a 4 or 5 year construction sequence and you may be dealing with 4 or 5 versions of upgrade on that project. Then if you contemplate that you have to upgrade all of the files. So it's not only all the model files that all your contractors have generated, but it's all the architectural and all the services files have to be brought up to date as well, the design files. So it's a significant problem. Don't underestimate it. So in summary, you need some fast workstations. I think Paul made the point it runs on today's hardware. It does, but you do need the latest hardware and particularly you need the latest operating systems. You need a fast network, you need some central storage, you need good backup. Those files are large. As I said, we had 600 megabytes of files on one project. If you have versions of those, you can see that your file storage starts to multiply very quickly. Very easy to throw a disk in the server and bump up the capacity. People forget about the backup. And IT will be complaining to you about the impact it's having on their backup times and their backup capacities. So put that into your planning. You can't get too fast an internet connection. Get the fastest one you can and the fastest one you can afford, but it can't be too fast. And beware of the impact of software versions. So that's it in a nutshell. I'll save the questions till the end of the day, but thanks very much.